All right, in this video on PSAT, SAT prep, we're going to discuss some of the vocabulary associated with scatterplots. Okay, it was somewhat difficult to find a question that was similar to the one that you had on your Google form, so if you missed it, I'm just going to go over some of the basic vocabulary so you can get an idea of some of the things that we concern ourselves with regards to scatterplots. So if you look here, I have three graphs on this screen, and then I have three descriptions of what's going on in each of the three scatterplots. And so I just want you to take a look at this first scatterplot. Notice that these points are in what you would probably call a linear fashion, or to say it a different way, if I wanted to, I could estimate what we would call a line of best fit. So if I were just going to try to draw a line that would get close to as many points as possible, obviously I'm not going to be able to draw a straight line that goes through all of the points, but I am, if I do it carefully, going to be able to draw a line that goes through maybe some of the points, but at least gets somewhere close to a lot of the points. And obviously my line's not straight, but you can see that's pretty good as far as a linear correlation is concerned. And notice that my line has a positive slope, meaning that it's increasing. And so what that means is that the more points I scored on quiz 1, which is down here on the x-axis, that means more than likely the more points I also scored on quiz 2. And so what we would say is that this is a linear correlation that is a positive association. And so I would connect that description with that graph. Now in the second picture, you can also see that these points, they line up in a linear fashion. So again, if you did your best here, you could draw a line of best fit that goes through maybe a couple of the points, but at the very least gets close to a majority of the points. And so one effort might look something like this, just for an example. And so we would call this a linear association that is negative because it is a line that has a negative slope or is going down or decreasing, however you would like to think about that. And so this second graph would correspond with the description that it is negative and linear. And then finally, the last picture doesn't have any correlation at all. You can see the points are totally random. There's really no way to correlate distance traveled to the number of times tardy. And if you think about the real world context of that, it makes a lot of sense because some of y'all would be tardy no matter how close your next class was. And that's okay. We still love you. And there's no judgment or condemnation there, but this makes a little bit of sense that there wouldn't be a correlation between these two things. And so you can see that play out in the scatter plot, just how scattered these points really are, and there is no correlation. And so we would connect that with no correlation. Okay, before we ended the video, I did want to show you a couple of examples of what we would call nonlinear correlations. And so this picture that is on the left here, notice that these blue dots are not in a straight line, so there's no way I could draw a line of best fit that goes through and is close to a majority of the points there. And so that is not a linear correlation. It's actually what we would call a quadratic correlation because the points line up in the shape of a quadratic function, which if you don't know what that word is, don't worry too much about it. What you really just need to know is that it is non-linear at this point. And then this picture over here on the right is also non-linear because you can see here this graph actually already has a green correlation drawn on it, and we would actually call that an exponential correlation. And that is a positive exponential correlation because as you can see, the graph is going up. And so if I can't draw a line of best fit, like these two examples and like the no correlation example from the previous screen, then we would say that the correlation is non-linear or that there is no correlation depending on the context.